you can just search for Mars Meet Simulator, and you can download the jar file Mars, that is I think Mars 4.5.jar. And as it is a jar file, you can use either Windows system or Linux. I don't know about Mac. Okay, you can try it out. And also you need to install also Java runtime environment, Java runtime environment JRE, to run this simulator. So basically it simulates the MIPS processor. Okay, so at first let me give you a little bit introduction. So here you can see some registers. Okay, there are 31 general purpose registers. Okay, and some of these registers are special feature, and some of these are general purpose. And in this there are another 31 register. This register can be used for integer operation or logical, and this register F0 to F31 can be used for floating point operation. And there are some special purpose registers. Okay. And this is the program counter. You know about program counter. It basically stored the address of the next instruction, and this is the stack pointer. This is the stack pointer. It will store the address of the first element of the stack. Okay. So I think up to this clear.
Yes, sir.
Okay. So let's start. Okay. So in this simulator, we have to write programs in assembly language. Okay. We are familiar with, I think, already familiar with high level language like Java, C, or Python. So at first, just write a basic program. Okay. Our purpose is to actually show you the row measure order, column measure order. You are using, suppose, the direct memory access, set associative, how those are stored in the memory. Okay. But to understand that, at first, let me give you a brief introduction. Okay, some small programs. So suppose I will write a program to print a simple string. Okay, suppose hello. So in MIPS programming, there are two parts. Okay, first part is data section. You need to write dot data, that means data section, and another part is called code section. Okay, it is written as dot text. In data section, you need to write any kind of data. In C, compared to C, you need to write variable name. Okay, actually variable names are basically the some addresses in memory. You are accessing those addresses using variable name. And in text section, you need to provide instructions. So suppose we want to print out, we want to output the string hello. Okay. So at first, suppose keep the variable name. I am giving the variable name as string1 colon str1 colon. Okay. So variable name should be followed by a colon. Right. Then the type of the variable. Actually, variable means actually this is not a variable. This is you are storing something inside the memory, and you need to declare the type of the store. Okay. And the type is ASCII. See here the description, store the string in the data segment and add with null terminator. Okay. And I will provide you some documentation. Okay, that will contain all these comments and what is those purpose. Okay, don't bother with that. I will give you the documentation after this presentation. Okay. Then ASCII is, that means you are storing some character, string, not character, array of character. Just write, suppose I am writing hello. So I am storing a variable name is str1. The type of the variable is ASCII, and I will after this presentation I will give you the documentation. And hello is the variable, actual variable. And in the test section, provide the instructions. Okay, so let me load li means load immediate. That means you want to load some value in some registers. Okay, and the value will be followed by the register name. See, here are some registers there, and to print string we need to use the variable v0. Okay, this is predefined. To print some string we need to use the variable v0. All right. Oh, sorry. You need to if you want to print anything, variable, integer, character, you have to use the variable v0, and after that variable for string you need to use 4. Let me write some comments here. As integer, for integer you have to use 1, or float, I think you have to use 2, double you have to use 3, for string you have to use. Suppose I want to print a string, then I have to use 4. Okay, 0 followed by 4. Then that means you are storing the value 4 to the register v0. So loading. After loading this, that means the processor will understand you want to print a string. Okay. Now just use the string address. LA means load address. You have to provide address of the string. There is another register called A0. That is the A0 register. Okay, and this is the convention. If you want to print some string, then you have to load the address of that string into this A0 register. So string address is str1, load address str1. Okay, and I am done. Load address A0 followed by str1. That means I have to store the address of the string str1 in the register A0. Now I need to call the system. System call means you are calling the system. System means you are calling the kernel function. You have written some operations and you want to perform that operation. For that, actually you want to display this. Actually, this will be displayed in your display device. Okay, but here this is a simulator, so in this case it will display here. Okay, IO. Syscall. Syscall means you are calling the systems. In this case, the kernel function. So just checking. Let me check it once. In data section, you have written the name of the variable, that is str1. Variable is hello, and the type of the variable is ASCII-Z. ASCII-Z means you are using string, and that will be terminated with null. Like see, here also you have to terminate the string with null. Okay. But it is, as you have defined with ASCII-Z, it is already terminated with null. So no need to rewrite it. In the text section, you have written some code, simple codes, instructions. That is li means load immediate v0 4. That means 4, this 4 value will be stored in the register v0. La means load address str1 to the a0. That means you want to print this string str1 in that display device. So just store this. I will save it. Assign 1 dot asm. The variable name should be followed by .asm extension. Okay, and be careful when you are writing this variable name. You need to follow the same convention as C, not the variable name. Sorry, the file name. Okay. That means you should not provide any space here. Okay. It should be started with some character, not some letter, not some number. Assign 1. Save. then readme assembly it quickly. Then it will be converted from assembly level language to machine level assembly. Okay, operation completed successfully. See, here is the text segment and here is the data segment. In text segment, see here the instructions are there and the data will be here. Okay. See, hello, data is stored here. This is basically the memory part, and this is the code. This thing also will be stored in memory. Okay. This is based on von Neumann architecture, your MIPS processors. So everything will be stored in memory, your code as well as data, but you need to write those things separately. In text section, you have to write the text instruction part. In data section, you have to write the data. Okay. Now let me know. Okay. See, hello. In string, the hello is string. One more thing. See, the visual register contains 4. Initially, it contains some garbage value, I think. Now it is contains 4. As I have stored the value 4 there. And also the visual register contains the address. Okay. So like this, you can write simple program. Okay. Up to this clear, I think. Am I audible? Please answer.
Yes, sir.
Okay. Up to this clear?
Sir, could you re-explain the last point, sir?
Yes.
Could you re-explain the last point, sir, that you said, sir, about the string part, sir, in the address?
This part. Okay. Suppose you want to print some string. Okay. That's why you have to store. Then you have to store 4 in the register V0. This is the convention. Okay. If you want to print some string in the output device, then you have to store 4. Okay. That's why I have write this load immediate 4. And then you have to provide the address of the string to the register A0. This is also the convention. Okay. That's why I have written LA. LA means load the address of the string str1 to the register A0. Then you have performed the system call. Then you are calling the system. That means you are providing the access to the kernel. Kernel will print this thing, whatever you have written here. Okay. Clear?
Sure.
Any questions?
No, sir.
Oh. Now, suppose you want to instead of string, you want to print some number. Then what will happen? So at first, I am using the. Let me change the variable name. Just count it out. Suppose your variable name is, in this case, you can give any variable name. That is up to you. Data 1. Okay. Followed by colon. Then space. Then you have to write the type of the variable. Okay. I want to store some integer value. Okay. That's why you can use either word data type or half data type. Those are predefined data type. Okay. What means your variable will take the whole word. Whole word means in this case 32 bits. If you define as half, then it will take up to half word. Okay. So let me write this as word. Then followed by the variable. Suppose I am writing variable as 130. Okay. This is the variable. Value of the variable. So type of the variable is word and the variable is 130, and you have to store the variables to the variable name data1. Okay. So here we have to change this thing. Okay. Initially it was 4. For integer you need to use 1. So change this to 1. And this is initially it was you are storing the address of the string, but in this case you have to store the word. Okay. For that the command is LW. See, load word. So you have declared the variable as integer, that is 130, and you have written here v0, 1. That means you are storing 1 to the register V0. That means you want to print some integer, and here you are giving the address of the word to A0. Okay, load one. Then you are performing the system. And save it. Still not finding the symbol. Okay, sorry. Not str1, the name is data1. Now see, here is your instruction and here is your code. This is instruction 1. Okay, okay, here the value 130 is printed. Let me show you one more thing. Up to this clear? So you have printed one integer, one string. Suppose now you want to print some floating point number or double. So I have told you to print or to store floating point, you have to use the registers, these registers, okay, from F0 to F31. Okay, so let me convert this code to print some floating point. Here, instead of what, you have to write float. Float. Store the listed values as single position floating point. Okay, and if you write double, that means double position. Okay, suppose number is 5.5. Now, to print a floating point number, you have to write here 2 instead of 1. Save this. Here also, yes, you are using a floating point number. So for that, the comment is L dot S. That means load floating point single position number. Okay. So data 1 is a floating point number. The value is 5.5. In the test section, you have to store 2 to V0. That means you want to print a floating point number, and you have loaded the address of the number data 1 to the register. Oh, sorry. In this case, for floating point number, you cannot use A0. For this, for the floating point number, the dedicated register is F12. If you want to print a floating point number, then you have to use the register F12. Okay. A0 is for string and for logical operation and for an integer, and F12 is for floating point number or double position floating point number. Okay. I think it is correct. Data section. Okay. Text section is 02 data 1. See, 5.5 is printed. So in this way, you can also print any double position number. Just write instead of this, write LD, and instead of this float, you use double. Okay, you will do it in home as an assignment. Okay, let me go to the next part. Okay, it is already 11:27. Okay, this time. So you have learned how to print a integer at floating point string, and for double you just perform it in your home. Okay, I will give you the full documentation. Now suppose you want to perform some addition of two numbers. The number will be stored in some register, and you only have to perform the addition and you have to write the output of that addition. Suppose the number are floating point number. First number is data 1 colon followed by dot float floating point number, then followed by the value. Value is suppose 5.5. The keyword dot float. So we have stored two numbers. One is 5.5, another is 6.5. 5.5 will be stored in data 1, the address pointed by data 1, and 6.5 will be stored that in the address pointed by data 2. In the text section, you need to give the command to perform the addition. So at first, you have to MIPS architecture is a load store architecture. That means everything you have to perform inside the register. You cannot directly perform inside the memory. Okay. Suppose something is in memory, then you have to copy that variable or value whatever from memory to the register. Then only you can perform any operation. So these values are basically will be stored inside some memory location pointed by data 1 and data 2. So at first you have to copy those values from memory to some register. You can use any register from this. Okay. So I am using register F0. So L.S, the code will be L.S, means loading 13 byte single position number, LS. Okay. Followed by your destination number is name is F0. Your variable name. Variable means actually the memory address. Data 1. Then L.S F1 register followed by data 2. So you have stored the value data 1 and data 2 into the register F0 and F1 respectively. Now we can perform the addition. So for addition, the command is yes, it is something like that. Add, see, there add. So you are adding floating point single position number. So use this add.s. Then this is the 3 address instruction. You need to provide 3 addresses. First address means first register will be your destination followed by your source. So suppose I am using the register F2 for destination, then followed by your register F1 and F2. Sorry, F0 and F1. F0, F1. So the value of S0, the content of F0 and F1 will be added and that will be stored inside the register F2. So addition is done. Now you want to print the result of the addition. You want to display the result. So for that you have to use LI, load immediate, again the register with the register for output purpose. You have to always use the register V0. Okay, I have told you all that. V0, comma. You want to display a floating point number, right? The addition, the summation of two floating point number is obviously will be floating point number. So, right? 2. 1 for integer and 2 for floating point. See, yes, I have written. Now, in previous case, if you want to print some string or some integer, then you have to use the register A0, right? You have to provide the address of whatever you want to print into the register A0. For floating point, you have to use the register F12. Okay, just I have to show you in previous case. So you need to move mov, see, move floating point single quotation, move the content of the register F2 to F12. So first write the destination F12 and followed by the source name. Source is your
Sir, one
F2.
doubt, sir.
And tell me.
Sir, why are we doing load immediate V02, sir?
Actually, this is provided with the documentation. Okay, for V01, yeah, for one for integer, 2 for float, 3 for double, and 4 for string. This is predefined. Okay, this comes with the documentation.
Okay, sir.
Okay, all right, and
Because,
also this.
sir, but after the addition, sir, like I didn't get that. Like, I'm not talking about the green parts. I'm talking about the line after addition. Add dot s f2 f0 f1. Sir, why, sir? Like, uh, sir, that is where the program should end, right? Because we're adding two floating points. So
Yeah,
why
yeah,
again
program
load?
is end here. Okay, program is okay end here, but you have to print now. You have to print that output. That's why I'm using this. Up to this
Okay, sir.
addition is performed, but if you want to print, if you don't want to
Okay,
print, then okay. But in this case, I want to print. Okay,
okay, sir.
clear. So you want to print the output. That's why I'm storing 2 to the register V0. Then move the content of register F2 dollar followed by the register F2. Then system call. Okay. So I have stored the value into two variable data1 and data2. Actually, these are pointed to some memory location. And then I have stored the data1 to the register F0 and the value of data2 to the register F1. Then I have performed the addition, that is add.s. Okay, this is very simple. You can just simply write and it will automatically show. H0 F1, the summation, the result will be stored in the register F2. Then suppose you want to print. Okay, up to this addition is done. Now we want to print the value. Then for that I need to load in the value 2 to the register V0 as here it is given 2, and then I have to move the content of register F2 to F12 because only the register F12 is connected to the display. Okay, if you want to display something, okay, then you have to put that value into the register F12, otherwise it cannot be displayed. This is the convention. Just it. Done. Assembly. Everything is okay, I think. So here is the your code section. I think it is okay. Let me check the data section. It is so small. Done. Now run it. See, the result is printed 12.05. Okay. 1993. See, the program counter is 40020 something like that. Okay. Suppose let me assimilate it again. Now I have resetted everything. Now the program counter is 4 something 400. Okay. After the program is done, it will store the address of the next instruction. That's why it has changed to 0. So up to this clear. Okay. How to perform addition. Instead of floating point number, you can also use integer or double. Okay. Just take those things as assignment. Suppose instead of
Sir,
floating point
what did
number,
you
you
say
want
about
to
the program counter?
what?
Sir, what did you say about the program counter? Sir, can you repeat
Oh,
please?
program counter. Program counter is actually initially assume this. Initially, the value of the program counter is something 400 something. Okay. Initially, after programming is done, it will be changed. Why? Because you have to. It has to store the address of the next instance. Okay.
Yes, sir.
Clear.
Yes, sir.
Now, what can we do? suppose like C programming, here also you can use function. Okay, function is always very useful. Okay, suppose you are doing some repeating task, then you have to use function. So how to use that function? Okay, let me show you one, quickly show you one program for function. Suppose I want to display, uh, repeatedly display some number. Suppose we change the data section. Just comment this out. Suppose I need to display something. And that will be a string. That's why ASCII followed by your string name. And this below. In the text section. Okay. Suppose I want to write functions. So like C, I am writing here two functions. One will be main function, and other will be some other function. Okay. So just write the function name. Function name would be anything. Function name followed by a colon. Then the poster will understand this is a function. If in your text section, if it is a main, then the poster will understand this is a function. Okay. You can write any name instead of main. Main 1, main 2, that will work fine. Suppose at first I want to display this line, but instead of directly displaying this line, I will use some function to display this line. So let's say the function name is display message. So at first you have to write this line JL. JL means this line will, if you write, okay, let me write it first. Give you any name. That means the processor will understand after this line. If you write this line, you can write this line anywhere. Okay, inside this line, I am writing this line here. That means the execution will jump to the function here, display message. I will write this function. Okay, just see. First, write some function inside the main. Okay, just some arbitrary function. Suppose I am adding at immediate. That means it will immediately add the number, two number, and the content will be stored in some register. Suppose I am adding something and that will be stored in the register. Suppose I am using integer. So you can use which register? You can use any register. Let me use S0. Comma. Here is a 0 register. 0 register means the content. This is constant 0. See, the content of this register is 0. So suppose comma 5. Then actually 5 will be stored inside this register S0. You are adding 5 with 0 and result will be stored in S0. And then I want to display this. Intermediate followed by this is an integer, then it will be 1. So for displaying some integer value or some character or string, you have to move that value to the register A0. So move 0, comma A0. So I am adding 0 with 5. That means 5 result will be stored in the register S0. Instead of S0, you can use S1, Q1, any register that is up to you. and I want to display this. That's why this is 1, and move the content of S0 to A0. Then they move to display. After this, you have to perform a system call. Okay. Now, as you are writing this as a function, okay, so you have to terminate the function. Okay, like C, whatever, like C, this is a return. Okay, return, execution return. So for that, you have to again use load immediate, and you have to use the register V0. And for this, the value is 10. It means the processor will understand you are terminating the execution. Load immediate V0 10. That means you are terminating the execution. 10 means you are terminating the execution. So let me write it. Now I am writing the actual this function. Okay, display message. Just copy this. Message followed by a colon. The function name should be followed by a colon. Okay. And the purpose of this function is to display this value. Okay. So we want to display some string. For that, again I have to load V0 with the value what? 4. We know it already. Then after that, I have to also load the address of that string. Okay. Load address to the register A0. For integer or string, you have to use the register A0. Then address display. DISPLA. System call. So what this function does? This function will display the value hello. Okay. For that, I am storing 4 to V0. This is the convention. To display a string, you have to use 4, and you have to load the address of the register to A0. Then perform system. After this, you also have to return. Okay. From this function to the calling function. That's why you need to write JR. Jump register unconditional. Okay, this is not any conditional jump, it's unconditional jump. Okay. Okay. So to unconditionally return from a function to the calling function, you need to write this command. Okay, gr followed by ra, return address. This register return address. This register contains the return address. Clear? Check me. Let me check it once. In data function, data part, you have written display followed by skz hello. Okay. This section you have written main function and display message function. Inside main function, at first you are jumping JL display message. DS, DLMS, okay, message this function. Then you are performing some addition with 0. The result will be stored in S0, and you are printing, displaying the result, that is P01. For that, you are moving the number from S0 to A0. Then system call. After that, you have terminated the function, that is li dollar $0. Okay, display message. This is another function. In this function, you are just printing the value of display, sorry, the content of display, that is hello. For that, this is string, that's why you have used 4. Then system call, then return to the calling function. Yeah. Alright, let's check it. Okay. Now just run it. Go. So this is important. Something is wrong with the function. Again. Sorry. Terminate this. These are both inside the infinite. Just give me a moment. Okay, I've put it. Oh, what is that? Oh, sorry. Okay, let me open it again. I think I have done something wrong. Okay, am I audible?
Yes, sir.
Yes. Okay, so let me open it again. What was the name? Yes, name was Vishwasat. Okay, let me check it again. I think this is going into some infinite loop. In data part, I have written display. Okay, in the text section I am writing main, then jump to display message, then add immediate is 005. Okay, then load immediate 201, move the pointer to 0, then starting system call. After load immediate 20, then I am calling display message. Load immediate B04. Okay. B04. Then load address of the registered display A0. Everything is okay, I think. System call jump array. Something is going wrong. I'm not getting it. B0, please terminate. I think everything is correct. Now I need to take this B0. I am terminating on now. I am terminating. Let me quickly okay, let me remind. See how it. Oh, this goes in such an internally. That's why it is not executing. Let me repeat it again. See, for that this is printing hello several times. That means I am calling this function several times. Not that. Okay. Okay. Let me go through the documentation first.
Then should mute their mobile phone. It's disturbing all of us.
let me go to the documentation page. So this is the documentation page. I will give you the documentation. Okay, I just check the addresses. You see there, 1 for integer, 2 for floating point number, 3 for double, 4 for string, and n for byte, and 10. 0 equal to 10 means exit. Okay. Just do it again. Okay, let me move on to the next program. I think I have done something wrong, but this is basically the format. You have to write whatever you want to write in data section, and this is the code section, and this will be your function name main, and then this will be your another function name, that is display message. And this is the conversion, I think, but I have done something wrong, but I am not getting it here. Let me move on. Suppose now you want to take some input from user. Okay, so what to do? So for that, suppose let me write. Suppose you want to take two input and perform the addition. To take two number and perform the addition. So inside the display, first number, so you are promoting to providing some input, then followed by ASCII. Okay. This will be prompted. First, this will be prompted first number, then this second number. Okay. Just comment it out. So at first you have to prompt this first number. Okay. So for that, load immediate. We are printing a string. That's why v0, comma 4. Then address of the string, that is load address, followed by your this is register a0, and that followed by string, and that is num1. Immediate v0 load address a0 num1. That means this will be prompted first number. Then perform the system call. Now you have to take the input. To take an integer input, you have to write this v0 by 5. Okay. 4 up to this is input support, this is for input. Okay, and from 5 for output. Oh, sorry, from taking input, this is for output, from 5 for taking input. So, So to take an integer input, you have to write load immediate v0 comma 5. That means you have to store v5 to the register v0. Then perform system. So at first this will be prompted first number. Then you need to give some integer value, okay, and that will be stored I think inside the register v0. Yes, v0 comma 5. After this this will be prompted, sorry, after this will be prompted first number. Then you have to provide some input, and also the value will be stored inside the register v0. So now v0 contains your input number. So actually we will again use this register v0. For that we have to move the content of v0 to some other register. So move it. So suppose I am using three register t0, 0 comma v0. So t0 contains your first number. Given the first input, and that will be initially stored inside the register v0, and from v0 I have copied the number to the register t0. So, now again you have to prompt give input to give output to take the second number. So for that again load v0 with 4, 0 comma 4, and then from this, it means we have to yes a0 num2. So I want to print some string, that's why this is 4, and the string name is num2. That's why we have loaded the address to the register a0 load address. Now you have to take the input from user, okay, for second number. So for that again you have to write this thing, this one, load immediate 0 comma 5. Okay, so you have taken the second number. You perform the system call. To register on, you can use any register. I am moving this number to p1. Content of first row file. P1 contains the second number. Alright. So at first you are printing load immediate v0 LA number. You are printing first number. Then perform the system call. Then you are taking the number load immediate v0 5 system call. You are moving the content of p0 to t0. Actually t0 now contains the first number. Then you are again performing this second number load immediate v04 load address a0 num2 in num2. This will print this. Then perform the system call. Then load v0 with 5. That means it will take another input. Then perform the system call. Move t1 with the content of v0 to t1. Now we are ready to perform the addition. Okay, so for addition, I'm just add. Then at first you have to provide the destination address. Suppose I am storing this in T2. By P1 P1 P0 will be added and the value will be stored inside T2. Okay. Now I will print the value. So immediate I want to print an integer. Okay, that's why I have to write 1. 0, 1. So for printing something, you have to move that number or value to the register agent. That's why I move 0. 0 will contain the content of what? T2, register T2. Okay. So here I have written in data section num1 and num2. That is basically first number and second number. This is for function, and I am loading v0 with 4. That means I want to print the string. The string is num1. And performing the system call. I am loading v0 with 5. Then I want to. That means I want to take input from user, and the input is integer type. That's why this is 5. Then system call. Move the content of v0 to t0 because I will reuse the v0 again, and then the content of v0 will be lost. That's why I am moving. Then load v0 with 4 because I want to take the second input. Again load address a0 num2. This after this line this thing will be printed. Then system call. Then load v0 with 5. That means for the second input. Then move the content of v0 to t1. Perform the addition. The result will be stored in t2. Then I am to write the output. That's the v0. I have loaded v0 with 1. And 1 is for integer output. Then I am moving the content of p2 to a0 because you can only write output, integer output or string output through the register a0. Okay. Then system call. Okay, I think this is correct. See, first number is 1 and the second number is 2 and the result is 3. So in this way you can take any input from user. I have written the code for integer input. You can also write the code for taking floating point number or double number. Okay, the documentation I will give. Okay, and in that documentation the code will be there. Okay, not the code. I mean this number. Okay, up to this clear, I think. So you have learned how to print some string, how to print any number, and how to write a function, but the function doesn't work for some reason, and how to take some input from user. Okay, up to this clear? Any question? Hello, am I audible?
Yes, sir. No, sir. No questions, sir.
Up to this clear? Now let me just for last program, let me write it down. Suppose you want to take some string input. Okay, string. String is basically an array of characters, right? So just let me show the string input. Okay, and you can perform it yourself for floating point number. For double number, you can perform it yourself. Just let me show you the. mm, I want to take an string from user. So let me write the data section and the course. the data section. Okay, I will take some arbitrary input from user, but before that, and then I will print it. Okay, I will print that arbitrary string. At first, I will print hello, followed by that arbitrary string. Okay, so for that, I have to store the message hello. Okay, so store the message hello, message colon dot ASCII hello followed by slash n. Then this will create a new line. That's why I written this followed by slash n. Okay, like C. Message ASCII hello. Now I want to take an string input from user. String is an array of character. That's why I have to at first declare the array. Okay, like C. In C you have to declare the array first. So in this case also you have to declare the array first. That will allocate some space for the string. So just like array 1. You can give any name. I am writing the name array 1. Okay. Array 1 followed by space. SPACE. These are the next specified number of bytes in data set. I am writing 20. That means it will reserve 20 bytes for the variable array1. Clear? It will reserve 20 bytes for the variable array1. That means your input string will be stored inside this array1. Okay. And for this the command is space 21. If this is space 30, that means it will allocate 30 bytes. You cannot store more than 20 bytes. Okay, like C. This is the maximum. Okay. Now, in text section, I want to take some string out, string input. Okay. For that, you have to again use the register v0, and to take an string input, you have to write v0 followed by a. Clear? Let me write it here. For string input, you have to write v0 followed by a. You don't do not need to memorize it. Okay, this will be provided with the documentation. v0 command. Then write the address of the array, okay, into the register a0. A0. I have told you already, for integer and string you can use the register a0. A0 followed by the array, the array name, address of the array. Oh, sorry. ARRY1, ARRY1, ARRY1. I think I am correct. So you have to store the address of this variable array1, ARRY1, ARR1 to the register a0. Okay. Also, you need to provide the maximum length of the array to the register a1. Okay, this is also the convention. In a0 register, you have to provide the string, in this case array, string address or array address, and in register a1, you have to provide the length. In this case, that is 20 bytes. Clear? So, this what we will do? This code, load immediate v0 command. That means processor will understand. Oh, this is a you are taking some string from user. Load address a0, add1, ARRY1. That means the string that will be given by the user will be stored inside this array1. Okay, and the maximum length is 20. Okay, this is the convention. In a0 register there will be a string address or array address, whatever, and in a1 register the maximum length will be there. Then system call. Okay, so at first I will write this hello, then I will print this. print whatever you have given. So load immediate v0 comma 4. You have to remember 4 means you want to output a string. Load immediate v0. Then you have to provide the address register that message message message. Okay. Followed by your array, input array. Immediate. This is also a string. Address. Okay, let me check it once. In data section, you have written the message MESSAG ASCII get hello. And the array array1, the length of the array is 25. In case section, at first you are taking input from user, that's why you have written dot immediate v0 followed by 8. Then you have provided the address of the array, load address to register a0, array1, check it once, array1, I think it's correct. Then load immediate a120, that means the maximum length of the array that will be stored inside the register a1. This is the convention. Then you have performed the system call. Then again load immediate v04 to printing this message. Then load address v0 comma message. That means message any this will printed. Then system call. Then you are printing whatever you have given as input. Load immediate v04 to printing is to print a string. You have to write v0 comma 4. You have to store v0 with 4. Then you have to provide the address. Okay, in this case, address of array error y1 to register a0 load at the system. Yes. Yes. Okay, so hello xy. Okay, so in this way, you can also take some string input from user and print it out. Okay, you can play with floating point, double. Okay, so I think for today we are done. Just up to this clear. If you have any doubt, just ask me. Up to this.
Sir, clear, sir.
Okay. Okay, I will mail the documentation as well as the manual, everything. Okay, I will mail the documentation sir and sir will mail you. Okay. Hello, sir.
Okay. And
Yeah.
sir, Bibhash sir,
Yes, any questions?
sir, not a question, sir. Sir, you told us to remind you after the weekend, sir, to upload the pipelining question, sir, on Moodle.
Not getting. Please repeat.
Sir, the pipelining questions, sir, the sums on Moodle, sir.
Oh, yeah, PPT.
Yes, sir. No, not the PPT, sir. The question, sir. There were some numericals you did with us in class.
Yeah. I will upload the PPT because the questions is given. Okay, I forgot. Okay, just give me a SMS on my WhatsApp. I will upload it. Oh, sorry.
Sir,
I
we
accept.
already
Sorry,
messaged
I
in the
forgot
group,
it.
sir. Sir, we messaged in the group, sir.
Okay, sure. I will do it. Don't worry.
Okay, thank you, sir.
But regarding the practical class, any question?
No, sir.
You just ask him because a lot of question may be there, but don't hesitate. Ask him, so he'll happy to answer all this question.
Okay, if you have any doubt, just ask me. Okay, this is a jar file actually, so you can use Linux,
Hasan,
Windows. That is up to you, huh, sir?
I think since they are not asking any question, just give some assignment to do by themselves in the home. Okay.
Okay, sir. I will mail you the assignment, and you
Yeah.
just mail.
Everything you just mail it so that they do
Yes, sir.
it by themselves.
Okay, sir. Okay.
So students, Hassan, can we
Yes,
conclude
sir.
the class today here up to this?
Yes, sir. We can conclude this up to this.
Yeah.
Okay.
So
Okay.
probably Friday we will take another class. Mr. Anindya Mandal will again take the classes on Friday consecutively. Like in this way, Monday will taken by the Mahabub Hassan Mahalat again. Okay, Hassan, for Monday your class will be again scheduled.
Okay. Actually, Monday we will do EFS loop. Okay, EFS loop, and I will do also some programming in studying grid mapping, asset mapping. Okay. So better you just prepare for that.
Yeah. So Friday we will taken by the Anindyan. Anindyan, you take the class Friday also. Okay.
Okay, sir.
Okay. Hello. Okay, so we can conclude the class today here. Friday we will meet again. Friday, Anindyan, Friday's time is 6 p.m. night.
6 p.m. night. Okay, sir.
Friday is 6 p.m. night. Dear students, you remember the time? 6 p.m. night. So today is 128 candidate present. Still 30 more students are missing. Okay. Inform them to attend. Otherwise, practical they get some problem. So I think it's a huge session. Time is cost. We are stop recording.